In lesson 21.3, we learned how to find the area of a regular hexagon using our knowledge of special triangles. The special triangle you created was the 30, 60, 90. And remember, we talked about how this is called the center of the polygon, just like it's the center of a circle. And when we draw a radius, is what that is called when you make a segment from the center to a vertex of the polygon. That's called a radius. It's the radius of the circumscribed circle as well. And we create an equilateral triangle here. So this side length of 8 is the same as the radius length. To find the area of a regular polygon, however, we have to know the apothem length. And the apothem is the segment that's drawn from the center and it's perpendicular to the side. It also bisects that side, so it's a perpendicular bisector. So we know that the interior angle sum of a regular polygon can be, or any polygon, can be found using the formula n minus 2 times 180. So when we put 6 sides in there, we learned that all of these angles have to add up to be 720 degrees. So since it's regular, all 6 are the same. So when we divide that by 6, we get each one of these angles to be 120 degrees. This radius bisects that angle, so we create a 60-degree angle here. So we have our 30, 60, 90 triangle that we can apply those rules to in order to find all of the information to find the area of that regular hexagon. So remember, there's 3 things that you have to know in order to find the area of a regular polygon. The formula is area equals 1/2 apothem times perimeter. Remember, capital letter for things we have to compute, like area and perimeter, and lowercase letters for single dimensions, linear dimensions like apothem. So capital A is area, lowercase a is apothem. The 3 things we have to know, of course, is the apothem, and in order to find the perimeter, we have to know how many sides there are and what each side length is. So these are the 3 things we have to identify every single time we're finding the area of a regular polygon. So we're going to apply what we have as understanding now to find the area of a regular triangle. Now remember, we have a special name for a regular triangle. It's called an equilateral triangle. We also have a name for a regular quadrilateral. We'll talk about that in a moment. But once we get to hexagon or pentagon and on, we don't have special names for regular polygons. We just call it a regular pentagon, regular hexagon, and so on. So just like with the hexagon, we're going to look at 3 different types of problems that you will encounter, where you're given the side length of the equilateral triangle, where you're given the apothem, and where you're given the radius. And so each one of these is a little bit different. Now in all of these, we're going to use the center of the triangle, just like we did the center of the hexagon. And we're going to create a special right triangle by drawing in a radius if it's not given and an apothem if it is not given. So on this one we're given the apothem, we just have to draw in the radius. On this one we're given the radius, we just have to draw in the apothem. Now remember, the apothem is a perpendicular bisector of that side. So on this first problem where we're given the whole side is 8, this perpendicular bisector, the apothem, created 2 side lengths that are each 4 because it's a perpendicular bisector. Now we also create a 30, 60, 90 drawing in the equilateral triangle. Remember, each angle of an equilateral triangle is 60 degrees. So this radius is bisecting that 60-degree angle, making a 30-degree angle here at the vertex, which means up here at the center has to be 60 degrees. Now that is flip-flopped from the hexagon. The hexagon had the 60-degree angle at the vertex and the 30-degree angle at the center. So it's always important for you to label which one is the 30 and which one is the 60 so that you use those 30, 60, 90 triangle rules correctly. So in this particular problem, remember, our goal is to find the apothem, the number of sides, and the side length. Well, all of these are going to have 3 sides because they're triangles. And on this one, we're given the side length is 8. So we just need the apothem length. So in this problem, remember, this apothem is a perpendicular bisector, so we know the long leg of that triangle is 4. We want to know the short leg because that's my apothem. So how do we go from the long leg to the short leg of a 30, 60, 90? Remember, we divide by the square root of 3. Every time we go from something longer to something shorter, we have to divide. And in the 30, 60, 90 triangle, it's the square root of 3 ratio between the short and long leg. So remember, we have to rationalize that denominator. So we're going to multiply the numerator and denominator by the square root of 3. So we get 4 square roots of 3 over the square root of 9, which is simply 3. Now, if these numbers outside simplified, you would want to be sure to do that, but they do not. So our apothem is 4 square roots of 3 over 3. So now we're ready to find the area, which is 1/2 apothem times perimeter. So we're going to have 1/2 times the apothem, which is 4 square roots of 3 over 3, times the perimeter, which is the number of sides, times the side length. Now remember, we're not rounding decimals as our answers here. We're giving our answers as simplified radicals. So if you put this in your calculator, you would put everything in except for the square root of 3, because that's an irrational number and forces you to round as a decimal. Now, most of the time, these are mental math problems that you could do in your head and really don't need a calculator. This 3 in the denominator, for example, will cancel out that 3. And 2 goes into 4 2 times. So now the only multiplication to do that's not the radical is 2 times 8. And we can do that in our head. 2 times 8 is 16. So we get 16. Don't forget your radical in your answer. Square roots of 3. And since this is area, you're always going to have squared units. Always make sure you double check that you use the correct units. Sometimes you guys give me answers like centimeters squared when it was supposed to be inches squared. So be careful about that. So there is my answer. It's not a decimal. It's a simplified radical. So in all of these, remember, our goal is to know the apothem, the number of sides, and the side length. That is what we're going to do every single time with every regular polygon that we're finding the area of. So in this problem, we're given the apothem. And of course, we know the number of sides is 3. So our goal is to find the side length. So again, make sure you label. Remember, this 60-degree angle was cut into half. So there's my 30, which means at the center is my 60 degree. The apothem is the short leg of that 30, 60, 90. I'm wanting to know the side length, so I need the long leg of that 30, 60, 90. So we do the reverse of what we did over here. Since we're going from the short leg to the long leg, we multiply by the square root of 3. So this long leg is 6 square roots of 3. Now remember, this apothem is a perpendicular bisector. So if this side is 6 square roots of 3, this short side over here is also, which is a long leg, but this other part of the side is 6 square roots of 3. It's a bisector. So the whole length of that side would be 12 square roots of 3. Remember, these are like terms that you're combining. They both have a square root of 3. So you still have a square root of 3 when you add them. It's just how many you have has changed. 6 plus 6 is 12. So that's the side length, 12 square roots of 3. So now we can find our area using the formula 1/2 apothem times perimeter. So we have 1/2 times 6. Perimeter is always number of sides times the side length. So it's just 1/2 times all of those values. So again, this is probably something that we can do in our head. We can simplify here. 2 goes into 6 3 times. So we don't have a fraction to deal with anymore. We're just multiplying 3 times 3 times 12. Well, 3 times 3 is 9, and 9 times 12 is 108, I believe. So I did that in my head. We might want to check that in the calculator. We can easily do that. If you want to put the whole thing in your calculator, you certainly can. If mental math is not your thing, I would always put 1/2 in as 0.5. So you'd have 0.5 times 6 times 3 times 12. But looky there, Miss Hale was right, 108. Don't forget, again, the radical in your answer, and your units are always going to be squared for area. So 108 square roots of 3 square inches is our answer. On the next one, we again are identifying the apothem, number of sides and side length. Remember, I drew in the apothem. That 5 inches does not tell me what the apothem is. It's telling me the radius. So the only piece of this information I know right now is the number of sides is 3. I'm going to have to find the apothem and the side length. So again, this 60-degree angle is being cut in half. So this is my 30-degree angle, and this is my 60-degree angle. The 5 inches is the hypotenuse. It's across from the right angle. So how do we go from the hypotenuse to the short leg? Remember, we divide by 2. So 5 divided by 2 can either be written as 5 halves or 2.5, since that's a terminating decimal. So terminating decimals are perfectly fine. So that's my apothem, 2.5. I know to get the long leg, I just simply multiply that by the square root of 3. So my long leg is 2.5 square roots of 3. Now remember, that's not my side length. That's only half of it. Over here is another 2.5 square roots of 3. So when I add them into all, I get 5 square roots of 3. 2.5 plus 2.5 is 5. So now I can find the area. It's 1/2 apothem times perimeter. So we have 1/2 times 2.5 times the perimeter, which is the number of sides, times the side length. So again, if you want to do mental math, that's probably one that would be able to be done, but we could also put in our calculator. 1/2 is 0.5 times 2.5 times 3 times 5. Everything except for the radical goes into the calculator. So 18.75 is the decimal. So we would accept that as 18.75 square roots of 3. Or if you wanted it as a fraction, you could hit math, enter, and say it is 75/4 square roots of 3, which is the same thing. So don't forget your units, which are inches squared. So either one of these would be appropriate answers on this one. In the next video, we'll look at the back of your notes, which is finding the area of squares. And by the way, that's not just side squared or base times height, so make sure you watch that video.